This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
This week we have Harold Thimbleby, who's from the University of Swansea, which is in Wales. I mistakenly said England at one point. It's not England, it's in Wales. And Harold has been working for many years in the area of human-computer interaction. In fact, I brought down, when I first really got into this field back in 1990, one of the books that I was impressed by and influenced by was his book on user interface design. And he is now just completing another book, which is taking the kind of ideas that were in this early one, but of course updating them for, 16 years now of progress and change in the field. Maybe progress, maybe not, depending on how you look at it. And what his particular expertise is in is looking at the kinds of issues that come up and the kinds of problems in interfaces and looking at the formal structure of the interaction as a way of diagnosing and fixing problems that come up. So today he's going to be talking about problems and solutions, general topic, but looking at interactive devices from that perspective.
Okay. Thank you, Terry. So I guess I should ask, is my sound on and can everybody hear me? It's on? Oh, well, thank you for coming, listening to my seminar. I changed the title a moment ago. I've decided to call it Problems and D-Solutions, because I mean, there are solutions and there are digital solutions. So D-Solutions to interactive device problems. So first I'll say where I come from and what I'm doing so that you have an idea. I come from Wales, which is just where I've arrowed. The university I'm in, the University of Swansea, is at the south end of Wales. And you have national parks, and we have national parks. And Swansea is next to a national park, the Brecon Beacons, and a different sort of national park called an Area of Outstanding Natural Beauty. It was the first part of the country that was designated as such. And it looks like this. Right, there we go. So these are photographs that I nabbed off the web last night. And to give you, I'll take you down the right-hand side rather than spend time on all the other things you can do. On the top is Weebly Castle that was built in 1304, I think. Underneath that is Pennard Cave. You can just see the black dot. And we say it's the most famous cave in the world. A body was found in there that dated back to 28,000 BC. This is the Swansea Marina, and this is King Arthur's stone. Apparently King Arthur was walking through Swansea and he had a stone in his shoe and he threw it onto the moor, and it's this sort of 20-ton thing that is actually an archaeological site. It's a burial mound, and how people in those days got these huge stones balanced on top of people, I don't know. That's probably why it's a burial mound, because you kill everybody underneath it. So you might say, if that is the area around the university, what's the university like? Where I work looks like this, and I work in this building, and the distance here is 4.5 minutes. So I'd love you to come and visit, and if you come and visit, you'll stay. I was asked about where I get PhD students. One of the problems with Swansea is most of our PhD students are undergraduates who go there, they like it, and they stay. I'm also writing a book, which Terry kindly introduced, called Press On. Don Norman wrote a great book called The Psychology of Everyday Things, or The Design of Everyday Things, and my working title for a while was The Computer Science of Everyday Things. And then I called it Press On and Push Off, and currently it's called Press On. So, what's this talk about and what are we going to do? You must have seen problems like this, where things go wrong, and there are all sorts of stories we could tell about things going wrong. The issue is, how are we going to make things better? Well, have you got any ideas? How would you make things better? I suppose that's a rhetorical question, isn't it? I think the way to make things better, and here is the International Red Cross telling you how to make people better, is you tell stories. First aid, true stories. You tell stories which engage people, which talk on the right level to the people who are listening. You've got to tell them stories that people want to listen to, that designers want to listen to, that referees, the research community, that your examiners. You've got to tell stories that people want to listen to. And the stories you tell, they've got to be understood by the people who are listening. And if we want to change the world and make it a better place, the stories you're telling have got to be ones that these people can act on them. Like they can pass your exams, or they can improve the gadget, they can spot the problem. And then, of course, you've got to have the stories, they've got to come from somewhere. You've got to have a genre of stories that people want to tell and they want to share. And if you get successful, you've got to have stories, there's sort of billions of things in Flickr and so on. You've got to be able to pick out the good ones. So, I'm going to start off with a couple of stories about me, and then I will suggest how we might do some of these storytelling things. I'm going to tell you a little story about this calculator. It happens to be a calculator that Casio believe is for primary schools, for young children, up to about 10. It's a simple, robust calculator, and it's got a basic user interface. The entire manual is this page and this page. That's it. That's the only description Casio provide on it. I'm fascinated by calculators, and one of the things I've done is I've written a Mathematica program which simulates the calculator. And I have wasted a lot of hours and plane journeys and so on, messing around with the calculator and the Mathematica simulation and sort of doing the same things on both of them, trying to get it right. What hidden state is there in the calculator that controls how it behaves? And so far, I think I've got 15 state variables in the Mathematica program tracking what is going on when you press divide equals equals and things like that. I know more about this calculator than I want to, but I've got a Mathematica program that just runs the calculator. So here is the simulation. It's a Mathematica notebook, if you like, Mathematica. You can press the buttons on it and it will do pretty much what this calculator does. Although, of course, it's a bottomless pit trying to reverse engineer any gadget, as you know. There are an infinite number of things this can do, and maybe there's some sequence like equals 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 will tell you the date it was built. And I have not yet tried every possible sequence. I've tried all of the sensible ones, and then I discover there's something peculiar and I have to modify my state machine underneath it. So, the question for you is, this calculator is clearly sold as a memory calculator. It's a basic memory calculator. It's designed for children and elementary use. So, I've worked out a number which happens to be 2.82843, and let me ask you, how are you going to store that number in memory? Like, what's the point of the memory but to store numbers in? So, an obvious task to ask is, how are you going to store the number you've just worked out in memory so you can go on and, for instance, do a chain multiplication or whatever you're involved in? Any suggestions?
Hit memory plus and see if the number doesn't change, then it's in memory. If it does, there probably was something else already in memory.
Okay, that's a good idea. If you press memory plus, the display won't change, you're right. But what it will do is add the number displayed to the number in memory, so you don't know what you put in memory. What I want you to do is get the number you can see displayed in memory. Of course, if the memory is 0, then adding the displayed number to memory will get you the display into memory. But how are you going to do it?
Before doing your computation, you would clear memory and then do
Before doing your computation, you clear memory. Well, there are some computations like sort of 1 plus 2 times 3 plus 4 times 5 plus 6, or a chain multiplication like that. Once you get going, you need to be able to store in memory. You can't clear the memory once you've got going. At this point, I've got a non-zero number in memory. That's what the M is telling you, in fact. So it's too late to put 0 in memory.
Yeah. Plus 0 times memory, recall memory minus.
You're onto the right sort of thing. It's not easy. And what you do is you get out a sheet of paper, you work out the sums this guy has been suggesting, and actually it would be easier just to write down the number you've got there than work out how to do it. So this is a Mathematica program, and it could have been a Mathematica program to simulate any gadget. And one of the nice things Mathematica can do is program transformation. Normally, user interfaces appear as a side effect of running the program. So it's very hard to reason from the program about what it does to the user. I've written a function in Mathematica I've called task to action that does the task to action mapping. If you've got a task, what actions does the user need to do? And this does some magic, which I'm impressed that Mathematica can do this at all. That do I get a mouse up there? Yeah. So store is a function I have defined in Mathematica that essentially says I want memory and display to be equal. That's all it says. I've said the set of all buttons on the calculator, that's what you have got, you can play with. And projection as user, I'm only interested in the display and memory. There are all sorts of funny state things inside, but projecting all that state down into just display and memory, I want display and memory to be equal. That's all I want to do to store. And I'm going to say initially the memory is 0. And you ask Mathematica this, and it says the solution is add the display to memory. If we, where's my pointer? If we have a more general assumption, which is number ready, the display on calculators like this, you probably know, either displays the number you're currently entering or it displays a result. Okay? Number ready means it displays a result and it's ready for you to enter a new number. The problem in some ways, I was unfair to you. I hadn't told you what that number was, whether it was ready or it was calculated. And in general, you can't solve the problem. But if it is ready for a new number, then the best solution is this. Minus memory recall, memory plus memory recall. I think calculators are bad. There's the problem with the memory. It's just a feature that stands out as a nicely coloured button that will help sell the calculator, and you get it home and discover you don't understand how to use it. There's a problem about feature interaction. A lot of calculators have, well, for instance, complex numbers and fractions so that you can teach children how to use fractions. Those are two features that both make sense. But have you tried finding complex fractions? And you'll probably discover it doesn't work. So that's a feature interaction that the manufacturer of the calculator hadn't anticipated. The percent key is another totally bizarre thing. Because I flew here and I reduced my weight, I didn't bring my kit of calculators, but I could have held up 4 Casio calculators from your sort of distance. They'd all look the same. I could either get volunteers or I could do it myself, but if you pressed exactly the same buttons, percent, on all of the calculators, they would give you 4 different results. If I asked you, what does percent do on your calculator? I guess you'd say, I don't understand what percent does. The evidence is the manufacturers don't know what percent does. Right? That's why you don't know, but we blame ourselves. Another issue is variables. Some calculators have got things like A, B, C and pi and so on. They work in very peculiar ways. If you try doing, say, a to the pi or pi to the minus 1, some of these things don't work because the manufacturers don't know how to parse arithmetic expressions. I've got this idea of user compiling. I think it's a useful concept. To know how to do a task, like multiply A times B or whatever, your brain has to behave like a compiler. Just like a Java compiler takes a Java program and compiles it down to instructions to change the state of a machine. To use a calculator or any gadget, you have to compile your tasks down to the sequence of instructions that change the state of the machine. And if you don't know exactly what the semantics of the instructions are, then you're not going to be able to compile reliably. And that notion of users compiling raises a whole range of issues, like how could you help the user optimize their code, how can you, and so on. It's a whole interesting way of applying computer science to user interface design. But the other side of calculators is they're very easy. It's a well-defined task. Like, since Frege, we've known what mathematical notation meant, and we want a referentially transparent, declarative, and so on, state-free user interface. The technology is really well understood. The technology inside this is not the limitation to how well it works. It's the manufacturer's competence to manage complexity. There are no technical limitations to what you can do with these things. Earlier this year, my son gave a talk, and presumably it's online and you can look it up, but we have built a calculator driven by computer science principles. We said, how can we build a proper calculator to avoid all these problems? And you end up with a different sort of user interface. Okay, so I've told you the story I've got about how to improve calculators or user interfaces for push-button things. Then how do you get that story connected to the manufacturers or the programmers, or to the next generation of programmers that you may well be? The talk, of course, is about problems in design and solutions with interactive devices. So let me up the stakes and go from calculators, which we can laugh about, like, if you can't store the number in memory, you can write it down. It's not really a problem. Well, here's a photograph from our hospital, and this guy in the bed is surrounded with a lot of calculators. There are 5 syringe pumps here. I don't know whether you know about syringe pumps, but if you end up in intensive care, you're probably anaesthetized, you'll have painkillers. If you're diabetic, you'll have insulin, and you'll have other stuff sort of fed into you. And these things on the left have all got syringes in them, and they've got motors that push the syringe like this very slowly, and they squirt whatever the chemical is into you to keep you ticking over while you get better. These things have got calculators in them. The consultant probably says to the nurse, give the patient so many mils of whatever per kilogram of body weight, and the nurse does a sum on the machine. Here's a typical incident which happened, I think, in Belfast Hospital. A doctor and a nurse were dealing with a premature baby connected to an infusion pump. And the infusion pump was set at 0.1 mils per hour, delivering stuff to the baby. The pump was in fact set on pause, so it had been set up to deliver this amount, but it wasn't delivering that amount. And possibly a sensible design, after a couple of minutes it starts beeping, beep, 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 because it has been told to deliver a certain amount of drug and it is on hold. And the designers thought possibly the nurses got distracted and they've forgotten to press the go button. So it makes sense. But in this case, it was distracting the doctor and nurse, and the doctor told the nurse to switch it off. She should have pressed cancel. You can imagine you're dealing with a premature baby and you reach over and press the button. In fact, she pressed 10, and 10 cancelled the beeping. And now the dosage was 10.1 mils per hour, and it started pumping. And 10, 15 minutes later, the baby was dead. And you can imagine, you believe you've just switched off the syringe pump. So when the baby starts getting distressed, it's the last thing you think of, and you end up killing them. It's very sad. The Institute for Safe Medication Practices wrote a report on this incident, and a bit I pulled out of the report said, we didn't feel that any criticism of the pump design was warranted. The device control panel is intended for single finger operation, and the 2 buttons described are situated an adequate distance apart. In other words, what I would view as a design error has been treated as an operator error. The operator is, in this case, the nurse is the fall guy. They either get sacked or they get sent on retraining courses or whatever. But rather than fix the design problem, the user is blamed. They made the mistake. Very often the medical agencies come out with device alerts that some device has got a problem, and then this comes to the attention. If the same error keeps on happening, eventually somebody will report it, and the authorities will wake up and they might do a recall or require the manufacturers to stick a label on the device saying don't press a button twice or whatever it is. So this one is unintended double key entries happen on this device. So when you press a button once, sometimes it counts the button being pressed twice. So recall the device. Baxter made some pumps, and there was just to give you an idea of the scale of the problems, the users might press on-off instead of the start key when attempting to start an infusion. And I'm not surprised about it. I've been in a number of operations, and it's very common for anaesthetists to get into trouble and switch the gadgets off and on again to reset them. So Baxter, the manufacturer of this pump, had received 6 reports of injury and 3 deaths associated with a colleague pump. The consequence of that is they recalled about $250,000 of these pumps. These pumps cost about £6,000 each, so it's a huge cost. And wouldn't it have been cheaper to have done some more user studies, better design earlier on? Or how are you going to get the stories from the anaesthetists when incidents happen back to the designers before it escalates onto this sort of scale? It's arguable the manufacturers are insulated to the problems for 2 reasons. One is the anaesthetists don't tell the stories because this happens every time. It's not an issue. And if there's no clinical incident, there is nothing to report. Baxter themselves say they've pioneered products that help reduce errors through the medication management process by advancing technology and improving the interface between technology and clinicians. And they have got a suite of products designed to reduce medication errors, including the colleague infusion pump. That is what they say, and yet the colleague infusion pump, they had to recall 250,000 of them. Cardinal make another gadget. This is one that is used widely in our local hospitals. This is the Ascena GH. And if I can point with my mouse, I just want to point out these buttons around here. This button tells you the pressure. This gives you some extra options you can get, and this purges the pump. So when you put a syringe on the front of the thing like I have here, and you connect a pipe to it, the pipe will initially have air in it. You press the purge button and it squirts stuff down the pipe until it comes out the end, and then you've got the air out of the system. That's purging. A more recent gadget is the Alaris GP volumetric pump, which is made by the same manufacturer. Okay, and you can see essentially the same buttons. Oh, that's interesting. My mouse jumps from one screen to the other. It's got the same buttons just there. The manual for this, which I'm afraid didn't photocopy very well, says these buttons, it features the same intuitive user interface as the pumps I've just shown you. Okay, let's put them side by side. Those buttons, yes, interesting bug we've got here. Those buttons there are the same as those buttons. Okay, so let me ask you, what do you think they do on this pump? That one. So on the syringe pump, which is the one that's got the syringe in it, they purge, they tell you the pressure, and they give you options. The same buttons are on the other pump, and the manual says they do the same things. Any suggestions? I mean, obviously, this is a setup. They don't do the same things, but what do they do? And you can imagine from the sort of intensive care picture I showed you, both of these gadgets could be plumbed into the same patient. Well, I'll take you out of your misery. Here's a photocopy from the manual from the infusion pump. The prime bolus button is for future implementation. The option button is for future implementation. The pressure button is for future implementation. That infusion pump costs something like $6,000, and it's got buttons on it that do nothing. And if if some medical emergency happens and the nurse reaches over to press a button, that button will do nothing, and the nurse will probably think it does something.
Is there any feedback? I mean, does it?
Yeah, it beeps. So it doesn't do absolutely nothing. It knows you have pressed the button. So the low-level software is handling it, and the manufacturer says somewhere on its website, we manufacture products that incorporate human factors design principles to facilitate ease of use and help minimize the risk of errors. I don't know, I suppose it's mean for me to say, but presumably the buttons doing nothing does minimize errors. Okay, I've got interested in syringe pumps, and I have reverse engineered a Graysby 3400 syringe pump, taken it to pieces, and I've got to know it really well. I wrote a Java program which simulates it, and I'll illustrate this program later. This is a screenshot of my simulation. I hold the pump over a scanner, scanned it in, and then wrote a Java program, and when you press the buttons, it does more or less what the syringe pump does. And I left a gap at the top of my simulation to put a picture in of the syringe, but I never got around to implementing that bit. From the Java program, I can, for example, draw the state transition diagram for the gadget. So this is a visualization of the program I have written. And you can do all sorts of interesting graph theory things on that, like, is it strongly connected? What are the hubs on that? Where are people likely to end up? Can you go into some state and undo it? Do you get stuck in places? There are all sorts of interesting graph theoretic questions you can ask. This is a picture taken from a manual of a syringe pump. And what I'd like you to notice is the manual for this syringe pump to explain how to use it for a nurse is essentially the same sort of thing as I showed you a moment ago, except it's been tidied up in Illustrator or something. That diagram is wrong. They could have generated it automatically and got it right, but it is presumably written by, I don't know, I'm guessing by a technical author or a graphic designer so that it looks nice and this is what it ought to do, and quite likely the way the device was designed is they probably started with a flash simulation, they showed it to anaesthetists and so on, and then they gave the flash simulation to technical authors, the programmers, and they then went off in different directions. That's a simple explanation of why this is wrong, but there's no need for it to be wrong. As I built the simulation of the Graysby 3400 pump, every so often I came across a strange feature, like it's got timeouts. And there are other strange features in it. Why are the timeouts? Well, I don't know. So here is my list of 38 queries I had. To me, as a HCI person, I thought these were odd decisions in its design. But I don't know much about how people use syringe pumps in reality. Maybe there's a good reason for having timeouts. So I went to the recovery room in our hospital and talked to some anaesthetists about the gadgets. And they all said, gosh, I didn't know it had those problems. Okay, so I write a paper about this and I send it off. So I'd now tell a story about the research I'm doing, and I send it off to, I think it was WIST I sent it to, and one referee says, graph theory and the related analysis techniques require a good mathematical background that many user interface designers don't have. Thus it's unclear how it can actually be adopted in the field. Right? Now, my perspective is it's hard work programming. You need some theory behind the programming, and if it turns out that graph theory is the right theory to use, well, that's what you've got to use. But if designers don't understand it, then the referees don't like it, and they recommended they reject the paper. So this story has not been told. And I'm afraid I can't resist telling you what another referee said of the same paper. I wrote myself as knowledgeable because I'm familiar with graph theory. I'm not convinced that modelling interactive systems with graphs is useful. Well, I don't know why not. A strictly graph theoretic model of a computational device can capture all the states in the universal Turing machine, but cannot capture the information, the content on the Turing machine's tape, which is unbounded. I'm afraid my mind boggles how somebody can say something that is so wrong. Like, he clearly knows about Turing machines and state machines and so on, and he claims to know about graph theory, but what he said is wrong. But he rejects it from ACM UIST. A few weeks ago I had a paper rejected from ACM Transactions on HCI, or CHI, isn't it? And again, two of the referees said, designers won't understand this paper. What's the point of it? Well, in my view, I'm trying to tell a story that is, HCI is difficult and you've got to manage the difficulties, and if you end up with a paper with a formula in it, well, that's trying to manage the difficulties. If you can help designers, that's a benefit, but I don't think it's, in my view, it's not a requirement. So, what we need are stories that connect. Somehow, I have to tell stories that referees like. Somehow, users have to tell stories that designers or managers or whatever it is like. Dundee is doing something interesting, sort of different spin on user-centered design. what they do is they, here is a story that has been created about an old person and a motion sensor being installed in her house. So the way these stories are done is, the issue is we want to build gadgets to go into old people's houses to help them have a higher quality of life. They then send a script writer to go and work with old people. And the idea of a script writer is you want to try and pull out the key stories and then create a piece of drama. And I'll show you how the drama is created in a moment. And then it's filmed with professional actors. And this is a storyboard from one of these little stories. So it goes, starting in the top left, Peggy, the old woman, is sitting at home and she's wondering. Then she tells the monitor on the ceiling that it's important that it works. And she then puts on some music. And then here she drops a jigsaw that she's getting out and it falls on the floor, and she gets down on the floor and starts doing the jigsaw. And the thing starts flashing, right? Because there's no motion and she's on the floor. And you're going to go on to the next thing? Yep. Then her daughter Jill receives a phone call in the top left. Jill rings up Peggy to see if she's all right. The mother's still on the floor when she hears the phone, and she gets up, you know, as an old person would, she gets up slowly, and Jill stops ringing just as she's trying to get to the phone. And then Jill here assumes there's an emergency. She rushes out of work and she's cross. She goes home and they have an argument with each other. And Peggy and Jill discuss what happens, and the final scene is Peggy is angry with the monitor that's led to this problem with her daughter, right? So it's a nice story. They create the script for that story, and they claim to be the only computer science department in the world with a proper theatre, and they have professional actors and the script writer. This is called forum theatre. They play out the story in front of, in this case, the old people who are the users who will be involved in working with these systems. And as they play out the story in front of them, somebody in the audience will say, oh, well, that's not right, or maybe this should happen slightly differently. And the story is improved. And in some cases in forum theatre, you say, well, okay, you know, come down and become the doctor, or come down and do something. And they get engaged in the story, and it becomes a very powerful story focusing on whatever the issue is for the story to tell. The problem is, this approach, powerful as it is, takes something like £10,000 per film. And they're long films. So are people going to watch them? Are people going to create them in the first place? Somehow you've got to scale up the technology so that you can make these more easily, and you've got to democratize it to make it accessible to people. So what we need, I think, are digital stories. And I'm going to, digital stories could mean anything, couldn't it? So I'm going to mean digital stories of a particular sort, and for the sake of argument, I'm going to call these things D-stories, so that you know, I mean, the particular sort of story which I'll explain to you. And the point of a D-story is to be accessible. In fact, digital stories, I think, were invented by Joe Lambert in 1994 over in Berkeley. And my story of how I came across them, they were picked up by a chap who worked for the BBC called Daniel Meadows, and he used them in a very exciting project called Capture Wales, where he went out and he got schools and old people and all sorts of people to write stories about their lives. And then my wife picked up on this, and she has recently set up the Swansea Digital Storytelling Centre, which I'll tell you about in a moment, where she's working on a deprived estate around Swansea, and she's helping people to tell stories to help transform their lives and their situations. The BBC Wales, Capture Wales site is there if you want to look at it, and it's full of lots of interesting stories. This is where my wife has set up the Swansea Digital Storytelling Centre, and it's a deprived part of the country, and the thing that she's had the community paint just there is one of these metal boxes that you can hit with a sledgehammer and you won't make any difference to it. And here are a couple of kids who are doing a digital story.
Quick question. Is a digital story just any story that happens to be stored in digital format? Or is there something
No, that's why I
else?
called it D-Story, so that I could be specific, or digital story trademark or something. So right now I'm trying to tell you, people are really excited about digital stories, or D-Stories, right? Clearly digital stories could mean, you know, the Spielberg thing, but these are, I'm trying to get you excited, anticipating. People like telling stories. You can make this list as long as you like. Blogs, podcasts, YouTube, Flickr. The Nokia N95 is a mobile phone that's got cameras and people use it for telling stories. The BBC gets 15,000 emails a day with people with stories. July the 7th in 2005, there was a terrorist bomb on the London Underground which killed lots of people and made a mess. And this is a photograph that Jill Hicks took, and she wrote a blog about it. The point I want to make is, here is somebody who's stressed, running away from an explosion, the smoke and stuff. She wants to tell a story about that experience. And this is her story. I won't read it out right now, but it is a moving, powerful story. She had her legs blown off. You know, it's wonderful that I'm here, but then of course it's clouded by the fact that I can't walk. It is a powerful communicating story about that incident in her life. She was, as it were, a bystander. The professionals also took pictures. So the professionals, the emergency people, couldn't resist taking pictures and telling stories about them. And these are some photographs taken by professionals at the time. Okay. After an incident like that, in Britain, when there is a serious emergency, particularly when police and fire and ambulance all get involved in a single incident, after it there is what's called a critical incident debrief, when people sit around and they debrief. Basically, the critical incident debrief is when people review the stories after an incident to learn about the incident and to manage stress. Two things are going on in these critical incident debriefs. One is, it's probably been a traumatic experience, so they are counselling each other, they're co-counselling each other. And the other is, there may be some issue with the technology or user interfaces, whatever it is, that they need to sort out and report to management. You know, the fireman there will say, my respirator, the respirator valve didn't work again, or the mobile phones don't work in the underground, we've got to sort this out. Unfortunately, critical incident debriefs usually fail at that level, because the firemen are always saying their rebreather systems don't work, or the mobile phones don't work, and they generate a lot of stuff that management can't cope with. Somehow these stories, you need to be able to share the stories amongst the people in the critical incident debriefing session, so that you're solving we're a community of people, we're working together, we support each other, but you also want to be able to say, that story has got to go up to management, it's got to be fixed. The technology you need, of course, is everyday. Something like this little iPack, it's got a camera on it. You could take a photograph, you could have it in your pocket, bring it out, take a photograph, and you could write your story on the other side and edit it and so on. The whole thing could fit in an iPack. So far as I know, there's no technology to develop digital stories. So people at the moment who are creating digital stories are fighting against either cheap, low-end stuff that doesn't do the job, or high-end stuff which does far too much and costs far too much and is incredibly complicated. Digital story, as I'm going to say, is very simple, and it's very accessible, and the technology needs to be simple and accessible so that you can have it on your mobile phone, you just bring it out, and it is easy to create the digital story. So, what is a D-story or a digital story? First thing is, it's under 2 minutes. It's brief, it's short. It's about 250 words, and this is really important. That length, 200, 250 words, is manageable. Children can write them, disadvantaged people can write them. It's not a hurdle to write 200 words. In fact, actually, in our experience of doing them, the hurdle is when you read the 200 words, some people find it quite hard to read for a couple of minutes, particularly when they're reading their own stories. The stories are in the first person, in the teller's own words and in their own voice. You don't get a professional to voice it over. You do it yourself about your story. It's taken with still images, possibly with transitions. If you made videos, then we all expect the production quality of videos to be very high, and then the technology becomes inaccessible. Instead, the digital story is made out of still images. They're easy to take with the camera, and you can photograph them and you can mess around with them. I think you Americans call them Ken Burns effects, that Ken Burns what's the word, popularized this way of, I don't know anything about Ken Burns or America for that matter, but some photograph of some, I don't know, the Boston Tea Party or drawing of it, he would photograph it and pan and zoom and stuff like that. Is that something like that? That's roughly what you do, and that's all you need to run on the iPad or whatever it is to pan, zoom, rotate, transitions between them. So you start with an incident and then you write a story. And this is a script I wrote and I scribbled on it when I read it out. And I'll play this digital story to you in a moment. It's about affordance, and it's a story that I took based basically on one interesting experience and one photograph, plus a couple of other photographs I pulled in to make it a more interesting story after the end. But I've only got one photograph of the incident. And here is another digital story I will show you. And I'm inside iMovie trying to build a transition. And iMovie, you've got these still photographs and my voice along the bottom. And I don't know whether you've used iMovie, but it's a complete mess when you want to do something simple and straightforward. I'm going to give you some example stories. And what I need to do now is find out roughly how long we've got. Got till 2.
Might be some time for questions.
Okay, that's great. So I've got a variety of stories. I've got a DVD from the Swansea Digital Storytelling Centre. These are stories made by people in the community. I've got a story one of my kids made about Lira in Uganda. That's an interesting thing because he did a degree in computer science and he earned a lot of money as a web designer. And he decided to go to Uganda to set up internet cafes. And he worked in Kampala setting up internet cafes. And then we got an email from him saying, Dad, I'm going to Lira. And Lira is a place about 20 miles from the Sudanese border. And you probably know in Darfur and Sudan and Uganda, it's an absolute mess. And for several months he worked in a refugee camp and he was completely out of touch and we had no idea whether he was alive or dead or whatever. And he took some photographs, and then when he came back, you know, my family, my wife and so on, we discovered about digital stories, and he made a digital story about his experience in that refugee camp. And in some ways it's a bit unfair to show you that digital story, but what it does is it is a very powerful story and it describes an incident in 1 minute 40 seconds. And when you watch it, I want you to, you know, it's about refugees and stuff like that. So the topic is not user interface design, but what I want you to get out of it is, if you've got some pictures, you know, the car radio has killed somebody because they were pressing buttons and they drove off the road. If you took a photograph of that, you could change the world.
Is a D story inherently something about a design issue, or it's just you happen to be using these as a good way to...
That's a good question. You've caught me in transition. I have seen digital stories, these stories, change people's lives. I've seen them communicate very powerfully. And some of these stories, this DVD came out just when I was marking a pile of MSc projects on user interface design. I don't know whether you've marked projects, but the students give you things, you know, this happens to be my book, but they give you things this size, and you've only got to look at it when you start wondering what's in the fridge, because that's much more interesting than sitting down for an hour reading these things. Digital story is 2 minutes, and I thought, hey, I'll get the students to make digital stories about what they would have written a 200-page project on, and then I can mark them in 2 minutes. And the students really enjoyed that, and I'll be honest, I've just started marking them, and some of them are fantastic. They're really powerful little things. You know, the students got excited about an experience with a cash machine or a ticket machine or their mobile phone. They've taken a few photographs and they tell a story about it. And if they sent these stories back to Ascom or Nokia or whatever, and people watch them, then I think things might start happening. Then I've got a story about affordance, which I'm afraid is a rather pedagogic story, because it was the first one I made and I was trying to tell my students what you could do. And so I'm sort of telling them what affordance is rather than saying I had a particular incident with affordance. And the last one is, I've been in operating theatres a few times, and this is a story I made out of one of those experiences. I think now is the right time to show you some of the stories. Now, that's interesting. I think I'm going to have to quit Keynote. Oh, that's interesting. It won't. It is quitting. Right. Oh, that's Three Cliffs Bay, which is a few miles from where I am. So let's start with the. It's going to work. With the syringe story. Did anybody see where my mouse went? Right, it's on the other screen. There we go. Right, so let's press the play button. So one of the things I learnt with this, I started with a black intro, and I would skip that next time.
Here we're outside Operating Theatre 2 in the Morriston Hospital. This is Mike the anaesthetist, and in front of us, although you can't see them, there's a patient lying down, and we're just starting to enter his weight into the syringe pump. There's no weight on his patient notes. He looks big, so is he 60 kilograms or maybe 70 kilograms? Maybe we have a discussion with him. Maybe he's 75. Oops, the pump is showing 5 kilograms. That's not right. Switch it off and on again. Now, of course, we need to start over and enter his weight again. What happened? Here's a close-up of the pump's panel. I'll enter a weight, 70 kilograms, say. Well, that works fine. Now, when the patient was present, we had a discussion about his weight, so we were a bit slower. Let's try. I'll start to enter 70. Well, let's make that 75. And the pump is showing 5 kilograms. The right thing to do now is press cancel, but the anaesthetist decided to switch it off and on again, then had to enter all the stuff again. Let's hope we don't need to enter any more numbers during the operation. In fact, it was a long operation, and we needed a new full syringe. Guess what? We had to switch the pump off and on again during the operation and re-enter all the patient's data again.
So, it's 1 minute 48 seconds, and if I sent that to the manufacturers, do you think it would make a difference? The problem is, of course, the manufacturers will say, if we change the pump, then you've got to recall them, retrain people, and improving the pump creates more of a problem than leaving it being a mess.
We have this sort of pump in our country.
Sorry?
We have these devices in our country.
The pump is made by Smiths, who own Graysby, so I imagine you do. One of the things that happened in that, when the anaesthetist switched, so we had a syringe of Diprivan, which is an amazing anaesthetic. So the guy is flat in front, and Diprivan's put into him, and the anaesthetist says, I want you to count down from 10, 10, 9. And the patient said, was out. The syringe pump has got a model of the, I'm not a clinician, I'm not sure what I'm saying, but it's got a model of the density of Diprivan in the bloodstream and how the metabolic processes get rid of Diprivan. And Diprivan's a nice anaesthetic because it's got no half-life. If you used gas, the longer you're anaesthetised, the longer you take to come round because the gas dissolves in everywhere in your body, whereas Diprivan doesn't do that. And if you, it was impressive. When he switched it off, the patient came round. So halfway through this 4-hour operation, we've run out of Diprivan, and this is my syringe pump here complaining I haven't used it. The syringe pump has run out of stuff, and a runner has gone to get a new syringe of Diprivan. You pull the old one out, put the new one in, you purge it, and you carry on. Except when he pressed the purge button, he got stuck. And he couldn't get it out of the purge mode back into carrying on. So he switched it off and on again. What does that do? That means you then have to re-enter the patient's weight, and it means the syringe pump has thrown away its metabolic model, or whatever those things are called. Now, in some senses that doesn't matter because the anaesthetist is a professional and it's actually he who is managing the arousal state of the patient rather than being left over to the syringe pump. So it doesn't really matter. But he didn't see this as an issue. It happens all the time. It's never reported. So I'll now tell you the next one I made. I had a little trip to Macau, courtesy of the United Nations, and they gave me a flat.
This is Macau. I'm trying to get back into my flat the United Nations University has lent me. I want to open the door, so I enter the code 1688#. The door lock buzzes, but the door won't open. I enter the code again. The door buzzes, but it stops buzzing just as I reach for it. It won't open. I enter the code again. The door buzzes. I grab the door, but it still won't open. I try again, this time lingering on the keys, then leaping at the door. It stops buzzing just as I reach it. It still won't open. I have another go and leap quickly at the door. It stops buzzing, but I stumble and fall into the door, and it opens. And I have a story about design. This door lock buzzes when the final key of the code is being pressed. It stops immediately afterwards. Unknown to me, the lock stays unlocked for a few seconds longer. If I pull the handle, the door won't open. Simultaneously with discovering the door won't open, the buzz stops, and I assumed that the door is locked, so perhaps the code's wrong. If I hadn't stumbled and discovered I was supposed to push, I could have been stuck forever. Handles look like you can twist, push, or pull them, and when the design is right, the twisting, pushing, or pulling works. The door will open. Some handles look like you should pull, but you're supposed to push them. A designer should match the handle's affordance to the door's way of opening.
So that's a rather teachy story, which I made for my students when I was telling them about affordance and stuff. But, again, it's, if you sent that off, 40 seconds of it to the nutcases who made the keypad and the door and so on, you could have sorted it out. And, let's see. Now I'll show you the digital story my son made, wherever it's appearing. Oh, it's here.
I saw about 10,000 people living in small tents, with maybe 4 to 10 people per tent. There was a block of toilets, with about 1 toilet per 100 people, and each toilet was smaller than a telephone booth. I couldn't see the end of the queue of people waiting. They were waiting for several hours because the truck that had been delivering food had run out, and there was none left for the people in the queue. I walked between the tents and saw people fitting bits of cardboard and plastic bags over the tents to protect themselves from the rain, and I could see last night's rain and how it cut little streams in the mud, even in places people might be sleeping. I visited them for a month and they welcomed me into their families. I met a little boy of 11 who was looking after his 10 brothers and sisters because their parents had been killed. They'd been killed by the rebels, who would attack villages at night and then force the children to kill their parents, so the children would have no home to return to, so they could be trained to fight against the people they'd been taken from. This war's been going on for 20 years, and they asked me to tell you they feel like the world's forgotten them.
So it's a powerful story, isn't it? And he's told you, so the world hasn't forgotten them. But the point is that a short story like that is easy to construct. People can't resist constructing them, and they communicate. And then what you need is to be able to communicate to the right people who can make a difference. So let me try going back. So I think what I'll do is, I've got a pile of community digital stories on this, but what I'll now do is talk a bit about what we could do. Now I hope I've convinced you digital stories are a really cool idea and we ought to get it all sorted out and change the world and create a structure where this is easy to do. So what are the benefits? You could communicate with designers. These stories could become design resources that designers making mobile phones could pull down stories about mobile phone use that are tagged or highlighted to say, this is how arthritic people use mobile phones or whatever it is. There are different sorts of things you could pull up. They'd also help engage users. If products had got, like the iPad I showed you earlier, if that product had a digital story tool in it, Hewlett-Packard or whatever could engage their users in the design of the product itself. It would make them more committed and it would make them more effective in the iterative design processes. In medical incidents in particular, there's a nice aspect of incident PR. I don't know whether you know, but Britain is currently installing the largest civilian computer system in the world to computerize the health service. It's costing billions of pounds. So most of the stories you see in the media are the Nuffield Orthopaedic Hospital went offline for a week and couldn't accept any patients because they had some problem with this new computer system. So when a nurse in the Nuffield Orthopaedic Hospital has a problem with the computer system, they ring up the BBC or the newspapers and it becomes a media disaster. Had Connecting for Health, the people who are managing this process, done better user-centered design, and for example, given people techniques for creating digital stories, when something goes wrong, because when you develop a system, things go wrong all the time, you train the users, make a story out of it, tell us. Now, Connection for Health would have collected those stories, and some of them would be, really exciting, positive things. We can now do X-rays faster or whatever. Let's tell Tony Blair that it's all working. And when there's a disaster comes in, well, you've trained the users to talk to the people who can sort out the disasters, rather than what's happened, in fact, is they've trained the users to ring up the media when there is a disaster. So what are the next steps? How are we going to make this happen? First of all, we need tools for creating stories. There are no tools that really are focused on making short, narrated stories out of still photographs. Once people are creating stories, you need tools like Wikis or Flickr or whatever it is. You need tools for managing thousands of these stories and for sharing them and so on. You also need tools for generating new media out of them. If you imagine you had 1,000 stories of the sort I've just shown you, you don't want to spend 2 minutes watching every one to find the incidents that are coming up. But the computers could generate, for instance, with voice recognition, or possibly the script was typed in to start with, you could have a picture and a title and a bit of script. And you could imagine having even a conventional media like this, a book of stories, and you can choose the stories from it and find things. You could index them and stuff like that. You could generate new media, not just the digital stories that I've shown you, but different sorts of things. You need to be able to retrieve the digital stories, and that's not an easy thing. The story, of course, has got a script in it, which was probably written, and you could use search engines and stuff, information retrieval, for pulling out the stories. Then you need tools for auditing designs against stories. So here are designers, and they have a tool that says, we have considered this story, and that's why that feature is in there. Or this story, you know, that's just floating around, and we're not dealing with it on this model. There is an auditing process. You don't want to lose track of things that are important and things that aren't important. You don't mind if you lose track of them. Or your manager might say, this story is a potential PR disaster. It has to be fixed. The device can't be released until you tick it off as being handled. And finally, there's a lot of research that could be done. Not just research in the computer science of building the tools that make and manage and so on these stories, but there's research about what is the right sort of genre to do this. I happen to be somebody who's been inspired by the potential for stories in user-centered design, but of course I might be completely misguided. It may be a very cultural thing. It may be something that works great in Wales but won't work in the United States or China or in different cultures. There's a lot of anthropology and so on. There are some interesting things you could study about the nature of storytelling and how technology can support it. And my contention that you need a 2-minute story, 200 words, you may be able to improve on that. But it's certainly the case that digital story tools that are around are horrible. This is one for doing podcasts, and it's, you know, FTP accounts and things. It's not how you encourage people to make digital stories. It's got to be much smoother than that. Microsoft in Cambridge have got an interesting project. This is a gadget that's on a wall, and you can see I have photographed it. That's my reflection in it. But there's a camera and a laptop in there, and when something interesting happens, you go up to it and flick the wheel and it spins round and it takes a photograph, and it's recording the interesting, in their case, social incident. So they imagine it, you might have it in your living room, and you know, your granny or whatever, hundreds of miles away, keeps up to date. When something interesting happens in your living room, like John has brought in some model he's built and this is fun, you flick it, photograph's taken, granny gets sent a sort of picture from Johnny, whatever. That's a nice way of telling stories. The operating theatre could have something like that on the wall. When something happens, you just wave at it and a photograph's taken, you go home and you can construct the story later. Microsoft have got a thing called SenseCam, which is you can see it's the thing you wear around your neck, and it's a wide angle, continuous viewing thing. You don't need to point it at anything. It just takes photographs of what you're doing. So you can imagine going home, and I want a tool that can take the video output from that camera and help you create stories, pulling out the interesting incidents. Maybe you need a button on it so it says, oh, you know, I must remember that. And when you go home, you've got, I must remember that pictures, and you build the story out of it.
How long would it take if you had some ideal tool? How long would it take somebody to make one of these stories?
Depends how perfectionist you are. Some of the people on the community take about half an hour from start to finish. Most of the stories, there's quite a bit of preparation in saying, no, this is the story I want to tell. And then they go out and photograph, and they write a script, and then they manage the photographs. So most of the time is deciding what story you want to tell. If you set up a storytelling centre, people come and they've got too many stories, too many resources, and managing that takes time. But stories that come out of incidents, like if you say to them, what happened this morning? And if they have got a photograph of what happened this morning, or they could write a story about it, and then they can create, they could say, something happened this morning, I want to write a story about that, and tomorrow I'll photograph what could have happened, and I'll construct it from a faked photograph. My family, every year it goes away, it hires a mountain climbing centre, and we have something like 40 of us, you know, sort of parents and grandchildren and spouses and so on. And we come together and we meet, and you can imagine different people in the family say, right, we're going to do walks, or we're going to play squash, or whatever it is. But this year my wife said, right, we're going to make some digital stories. And half of the people there, with ages ranging from 8 to about 60, made digital stories in a couple of evenings. And the way we illustrated the stories, because people hadn't come with stuff, we brought a scanner with us to scan in pictures. One kid drew a story. They drew a storyboard, they scanned in their drawings, and then they voiced over with a couple of their nephews one of the stories they made from drawn pictures rather than photographs. And I think everybody else pulled off close matches from the internet. They used Google to find images which were about what they were trying to tell the story. So one person had a scary story about a caving incident she'd been involved in, and she pulled off pictures of other people going caving. Tony?
I'm interested in that. One of the elements that you emphasize here is the personal connection, first-person notion. I was thinking about using this in a course where people do designs. Their story would be more like your old lady story, where it's not, the person telling it is fictitious, but it's trying to give the feel of what it would be if that person exists.
Right.
Is that a way you use it, or is it really only for sort of first person?
Okay. Well, that's a good research question. I believe the first-person story about my own experiences communicates much better. But if you're a designer and you're creating scenarios, would you do the scenario in the third person or the first person? Would you act as if you were the character? I don't know, and it would be worth finding out. So, one of the issues as soon as you start trying to make digital stories is the authoring side of it is a mess. There's nothing that's convenient that can do script editing. There's no auto cue. Quite a lot of people find it hard to read a script, and well, the two scripts I've spoken and you've listened to, it took me several takes to get it right, and I'm still not happy with them, and I could do more takes. Quite a lot of people are shy, and you know, it's hard. But much easier if you typed in your script and it had an auto cue and was going past, and then if there's a bit you mess up, you can just replace that part of it rather than having to do the whole lot. It'd be really easy to implement, and it would transform the voicing part of it. The script synchronization is, as you saw with the picture of iMovie, you've just got an oscilloscope signal along the bottom. You have no idea what you're saying, and when you're trying to line up pictures with bits in your story, it's actually very hard to do. Whoops, have I gone on too far? The transitions and morphs that you can do in every program I've looked at are very restricted. They make a radical distinction between the transitions you can do within a picture and between pictures. So if you remember the story about affordance, I had a single picture where we went backwards and forwards as I was doing something over here and doing something over there. In iMovie, that took something like 20 copies of the same picture, because you do the transitions between pictures and you can't go backwards and forwards within one picture. You have to go across another picture, go back, another, and then if you're going across and back, you have to line these up, and it's a mess. Titling is tricky. What does I mean by rapid assembly? I don't know. Well, you can. So you've obviously got to be able to assemble these things rapidly. I'm not sure what I meant. It's one of the problems of telling stories using a script like this. Management. What about having a wiki site which sort of work like a wiki? Lots of people can contribute to it. You can have private and public areas. These are, for instance, our incident debriefing stuff, which is private. We're going to rate it, and some of the things are going to go up and become public or become available to managers or whatever it is, because these are things we think should be sorted out. You want to be able to tag the stories. You need multiple classifications. you need some sort of hierarchy, because as you create stories, lots of them will be about, they'll cluster around a certain topic, so you have a hierarchy, just like Wikipedia creates hierarchies out of different themes. A conference I went to recently, a computer science conference, one morning I sat down for breakfast and I deliberately chose to sit next to somebody I didn't know, and there was another conference going on in the hotel with the Red Cross. And the woman I was sitting with was she was the international disaster manager, or she managed international disaster recovery from London. And I told her what I was thinking about digital stories. I explained it with the example of my son's story from Uganda. And I said, well, how will this help the Red Cross? And she called a couple of colleagues over, one who'd worked for 15 years in the Philippines on displaced people. So people, when things go wrong in a country, people get displaced, and that creates problems the Red Cross sorts out. What stories would that woman who'd been working in the Philippines tell? What she did, in the way the Red Cross works at the moment, is every month she writes something like 15,000 words reporting on what's going on. Those 15,000 words basically end up in a filing cabinet. When I told her about the digital stories, she told me a story that one of the things she'll never do again, and everybody else must know about, was she took, I think, several village leaders across a river, and the boat sank, and she lost all of the village leaders. Right? So next time she does it, she will take the village leaders across in separate boats so that you don't destroy, multiple villages all in one go. That's a nice story. And it's a very powerful one that other people need to know. And then a chap from Uganda said, he was dealing with mine clearance, and he said the story in the old days used to be the heaviest person walks in front. And now the story is the mines that are being used are nasty. They reconfigure themselves. So if you walk across a mine and it blows up, it doesn't mean it's safe to walk there, because adjacent mines haven't been triggered, and they reconfigure themselves to sense where, that mine used to be sensing this little patch. It's blown up, and now adjacent mines have expanded into that area. So now, just because somebody's blown themselves up doesn't mean it's safe to follow them. That's a story he wanted to tell. So that's what that was about. What about projecting onto different sorts of media? I showed you some video digital stories, but if you want to have a collection of them, you want to be able to have, say, the key frames and a little subtitle to pick them out. Those things could be pulled out automatically. They could project onto other sorts of media, like an A4 summary. You want a sheet of paper, a poster that says, this is the story about Uganda or affordance or whatever it is. You might just want the voice for a podcast. You might want to put it onto TV like the BBC does. You might want to convert it into a PDF. You might want it as an object that you can email to somebody else. One of the problems with converting it into something like QuickTime is you create enormous files, and yet you've only got 3 photographs and 2 minutes of sound. There's no reason for them to be enormous files, but QuickTime stores the transitions in an inefficient way, and they become too big for most people to be able to email. What about sharing them? Well, I've mentioned you want to be able to audit the stories. Who's viewed them? Has your manager actually listened to you? It'd be nice to know whether your manager's listened to you. Who's acted on it? Can you prioritise them? There are all these stories coming in. Some of them are more important than others. Some incident debriefing groups say this must be done, or how do you rate them? What's been missed? There's a lot of research, as you know, with tagging and rating images in things like Google and Flickr and so on. Those ideas could be taken over into digital stories. So, almost near the end of my talk. The message I want to get across to you is let's do it. I believe digital stories, or some variation of them, will empower people to improve, in particular in the domains we're working in, to improve user interfaces. It'll mean designers and manufacturers and managers can learn from incidents which currently are just getting lost and not reported. The culture we started by mentioning, like, you think you don't understand percent, but in fact the manufacturers don't understand percent. People don't create those stories and pass them up, and nobody realizes that everybody else has got the same problem, and therefore it's not their problem, but it is a design problem. The technology, even when it's difficult to use, is simple, it's accessible, and some people are addicted to them and they start churning out, and blogs are a good example of this. People can't resist communicating. It could be team building when you've got a group of users all using a similar technology. You could empower them to work together to create their own wiki-like digital story site. I think it's feasible, and I think there's quite a lot of work that needs doing. We need some tools, we need some research and evaluation to answer the obvious questions like Terry was bringing up. What sort of stories work best? Okay, so what have I said in this talk? I've said that interactive devices are a mess, and I only took I took three examples. I took calculators, syringe pumps, and digital story tools. They're all disaster areas, and anybody who wants to improve those things, the world's wide open to improve them. Devices are a mess, and you could have added all sorts of other things as well that need sorting out. We sit around complaining about these things, or I sit around writing papers about them, which is just a more sophisticated way of complaining, but the people don't listen. The referees reject the papers that complain because, they have got they use Texas Instruments calculators, not Casio calculators, so what's my story? Somehow we have got to tell stories that are connecting to the people who we want to take action. So we want to connect to referees, we want to connect to designers, and we want to connect to managers, people who can change our job because this is the system we're working in. And what else have I said is people want to do this. So I hope I've encouraged you to go out and try and help them. And of course you could come to Swansea and help them over in Swansea. This is Three Cliffs Bay, and I think I've got my facts right. The BBC has a television programme, oddly enough, which wanted to find the best beach in Britain. This is the best beach in Britain. And the Times, I think, had a survey for the best beaches in Britain. And as I understand it, because I didn't read the articles, but this is the best beach, and just up there is the second best beach in Britain. So the funny symbol I've got on the bottom right is the logo for the FIT Lab, the Future Interaction Technologies Lab. That's the lab I've just founded in the last couple of years at Swansea. I'd very much welcome visits from you. It's a nice place to come and stay. Okay, so that's the end of my formal talk. I'd love to have some questions and comments and criticisms and so on from you. Okay, thank you. So,
your original problem was with the journals, and your solution is e-stories. So I suggest you found an online journal of e-stories.
Right. Yes, that's good.
Can you repeat the question?
Yeah, sure. This guy, Tom, said my original problem was with referees and journals. What I ought to do is start a journal of digital stories. It's a nice point. In fact, an online one, yes. I certainly agree with you, and it's a good point. But really, my original problem was not publishing, but I want to make the world a better place. And as a professor and an academic and so on, I believe one of the best ways of doing that is thinking abstractly and analytically about the problems and publishing those so that people can pick up the intellectual tools to improve the world. So the real problem I have is I want to make the world a better place, and I think digital stories will help make the world a better place, possibly faster than conventional journals, which is really what you're saying. A digital story thing about HCI, ACM, sort of DCI, or whatever it's going to become, could be a really powerful medium. Thank you. Yeah. Johnny, Bonnie.
Yeah, I think we do that all the time. So originally you were talking about the infusion pump and how it was wrong. Okay,
Right.
how it didn't match instructions and all that sort of stuff. And you could debate which was wrong, the instructions or the implementation. But I've worked with people who make infusion pumps actually, and their research groups, when they design them, they do ethnography. They go out to the labs. They're motivated to get this right. They have specs that they've done in many different ways, and yet you've discovered that the implementation is wrong.
Right.
Okay.
Absolutely.
So I thought you were going to tell us how D-stories could help that, but your D-stories are more motivational. Now they'd be more motivated to get it right. But I think they already were motivated to get it right and they got it wrong. So
no, I think it's a big problem, and I would say the key problem, the main reason why most systems are bad is that manufacturers employ programmers who aren't very good, and nobody realizes that. So the managers in the organizations are happy, they see a demo of the thing and they say, oh, it works, let's ship it. And they don't realize the program there has got lots of conceptual problems and bugs because it was implemented by somebody who could only just cope with what they've achieved for the demo. So I think the digital stories that say, here are some, obviously I'm a computer scientist, and if I was an anthropologist I would answer your question in a different way, but computer science would say, here are some issues which are computer science bugs causing problems in the user experience. And the manufacturers are not taking that sufficiently seriously to recruit competent programmers.
I just think that's, this thing with the 75, right? Whoever wrote that thing, if you had said, make sure when you do 0 and then erase it, in 70, you get 75 and 75, or whatever it was, I guarantee whoever wrote that is smart enough to do that. It's a design issue. It's not an implementation. I mean, it's not like I know how to put a 5 on the screen, but I don't know how to put 2 digits on the screen when someone.
I don't think it is a design issue. I think it's a programming issue. My interpretation of it is the program is large and complicated. If it hangs, there is a watchdog in the program, and 5 seconds later, when the program's done nothing, it resets itself. It's there because it is a bad program. That's my guess. And it just happens to, if the user hangs and not the program, because the user delays, in that case, the anaesthetist was having a chat with the patient. The device doesn't know that, so it thinks it's hung, so it resets itself. And it's a watchdog in there to stop the program crashing completely and getting stuck. So I think it's a programming problem. It's a fix for a programming problem, not a design decision as such.
I'm sorry, that's a design decision.
yeah.
Oh, it is a design decision at that level, yes. It's a design decision driven by programming compromises.
If you have further questions, feel free to come on down, and thank you.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.